Okay, hello Cloud Gurus and welcome to this lecture. This is the VPC Lab Part 1. We're going to go ahead and provision our own custom VPC. It's lots of fun and you're going to learn an awful lot. So this is a lab and you will need to log into the AWS console. Okay, so I'm logged into the AWS console. If we just go down to Security, Identity and Compliance and we click on Cloud HSM, we'll be able to see where Cloud HSM is available by going up to our regions and selecting a region that's closest to you. So you can see it's not available in London right now or in Seoul or in Sao Paulo, but in the other regions it is available. It's completely up to you which region you choose. By default, though, all the new services tend to come out in Northern Virginia anyway, so I like to use Northern Virginia. So choose a region that's suitable for you. And what we want to do is we want to scroll down. We're going to Network and Content Delivery, and down here you can see VPC. Click on that. We're going to get a VPC splash screen. We could go in and start a VPC wizard. If we did that, we wouldn't learn anything. So what we want to do is go ahead and create our own VPCs without using a wizard. So what I'm going to do, before I start, let's just have a quick look. So we've got subnets. These are all, if you look at the IP4 address, these are all using 172, so they're using that network address range. These are all my default subnets inside my default VPCs. This is created for me automatically by Amazon when they first set it up. Route tables, I've got one route table in there for my main default VPC. Internet gateway, I've got one in there for my default VPC. We just scroll down to security groups. In security groups, I've got a web DMZ, which I created earlier. I've got an RDS one, which is left over from another course. And then I've got my default security group, which is created automatically when I create my VPC. So let's go in and create a new VPC. In terms of naming it, call it anything you want, but I'm going to call mine a Cloud Guru VPC. The CIDR address range, I like to use 10.0.0.0/16 because that will give me the biggest address range possible for a VPC. In terms of the IPv6 CIDR address range, you can have IPv6 or not. I am going to do it just because it gives me more options later. Tenancy, we can have default or dedicated. If you have a dedicated tenancy, it means that it's going to be on dedicated hardware. No other, other AWS customers would be sharing the hardware with you, but this would become quite expensive. So I'm just going to say tenancy as default, which means it's a multi-tenant environment. Go ahead and create your VPC. Now, as soon as we create our VPC, a number of things will be created for us, and this includes route tables, as well as, well, let's go in and have a look. So if we click on subnets, all our default subnets from our default VPCs are still there. It hasn't created any new subnets for us. If we click on our route table, we can see in here that a route table has now been created. So it has created that automatically. If we click on Internet Gateway, we'll be able to see that no Internet Gateway has been created for our VPC. We've still got our default one. And then if we click all the way down to our network access control list, we have now got a default network access control list. And if we click on security groups, we have now also got a default VPC security group. It's up here for our VPC. So whenever you create a new VPC, it's going to create a default security group, a default network access control list, as well as a default route. It won't create any subnets. You have to go in and create the subnets yourself. So essentially, this is all we've created so far. We've basically created our VPC. In doing so, it's provisioned a route table, a network ACL, and a security group, but everything else is empty. The next step is we have to go over and create some subnets. So let's do that now. Okay, so to do that, we just go over here to subnets. We can see all the default subnets for Virginia, Northern Virginia. So I'm going to go in and create my own subnet. I like to have a very particular naming convention, so I like to identify both the subnet CIDR block range in the subnet as well as what availability zone it's going to go into. So I'm going to call this 10.0.1.0 and then hyphen and then the availability zone. To get the availability zones, first of all, go in here and select your VPC, and then in here click your availability zone. So this is going to go into US East 1A for me. So US East 1A. And by the way, just an interesting tidbit, US East 1A in my account can be a completely separate availability zone to US East 1A in your account, but they will share the same name, but they can actually be different availability zones. The reason Amazon randomized the availability zones on a per account basis is because look at me, I'm just picking the very first one that's available. So if everyone was doing that across the AWS landscape, then US East 1A would be the most heavily oversubscribed availability zone, and then US East 1F would pretty much be empty. So US East 1A to me could be a completely different availability zone to US East 1A to you and your AWS account. So it's just something interesting to know. In here, we're going to do our CIDR address range. So you can see I've already put it in my name tag. So I want this to be 10.0.1.0, and then it's going to be a /24, which is going to give me 256 IP addresses, but I'll only be able to use 251, and we'll see why in just 1 second. You can click in here and go specify a custom IPv6 CIDR. It's completely up to you whether or not you do that. I'm going to say don't assign an IPv6 CIDR because I'm not going to use it in this, in this lab. So go ahead and create your subnet. That will create your very first subnet inside your A Cloud Guru VPC. Okay, so my subnet has now been provisioned. You can see it in here. It's got a very useful name. It tells me the CIDR address range and what availability zone it's in. You can see that it's in my custom VPC because it says it's so here. We can see that it's a /24, and there's only 251 available IP addresses. So I wonder what happened to the others. I mean, /24 will always give me 256 ranges, according to CIDR.xyr or XYZ, whatever the the web address is. So let's go over to Google. Okay, so I'm in Google and I just typed in reserved AWS VPC IP addresses, and the link you're looking for is docs.aws.amazon.com/Amazon VPC/latest/user guide VPC subnets. Go in there and just click on VPC subnet sizing and scroll down. And you'll see here it says that the first 4 IP addresses and the last IP address in each subnet CIDR blocks are not available for you to use and cannot be assigned to an instance. So the first one's the network address. The second one is reserved by AWS for the VPC router. Third one's to do with DNS. Fourth one they've reserved for future use. And then this is the network broadcast address. And because they do not support broadcast in a VPC, they reserve that address. So you're always going to lose 5 IP addresses every time you provision a subnet. So do remember that going into your exam. So I've got one subnet that's not very highly available. Let's go ahead and create our second subnet. We're going to call this 10.0.2.0. I'm going to make sure it goes into my VPC, the one that I'm creating. I'm going to select US East 1B, so a separate availability zone. So I'm going to type that in the name as well. So US East and then 1B. And then I'm going to go ahead and give it a address range of 10.0.2.0 and then /24. And in here, you can actually see my CIDR address range that's available to me for my VPC, both from an IP4 and IP6 directory, and that it's associated to this VPC. So I'm going to go ahead and hit Yes Create. That has now created a second subnet. So now I've got one subnet in one availability zone and one subnet in another availability zone. You can see them here. If I was you, from a UI point of view, I'd just sort by VPC, especially if you're in a region where you've got lots of different subnets. That way you'll always see the subnets at the top that are associated with your VPC. Okay, so this is what our VPC looks like right now. We've got our 2 new subnets, 10.0.1.0 and 10.0.2.0. There's nothing inside them right now, and they're both private. So let's go ahead, and what we need to now do is go in and add an internet gateway so that we have some kind of internet connectivity. Okay, so to add our internet gateway, we need to go in and go to Internet Gateways. We're going to go ahead and create an internet gateway, and we'll call it my IGW, and go ahead and hit Yes Create. That creates, and by default, it's automatically detached. So the first thing we want to do is go in and attach it to a VPC. There's only one VPC available for us to attach it to, which is our one that we've created. So yes, let's go ahead and attach that. Just to prove a point that you can't have multiple IGWs on a VPC, let's just create a bogus one. I'm not even going to bother naming it properly. If I go in and try and attach it to a VPC, I've got no VPCs in which to attach it. So that can be a common exam question across, across all of the exams, really. So I'm just going to delete this gateway. The next thing we need to do is go into our root tables. And so we're going to go over to our root tables in here. And in here we can see we've got 2 root tables, both created by default when we created our VPC. Now, these two rules in here basically are allowing our subnets to talk to each other or to communicate each other by default. So that's all that those rules are doing. In here, we've got our subnet associations. If you read here, it says, you do not have any subnet associations. The following subnets have not been explicitly associated with any root tables and are therefore associated with the main root table. So this is our main root table. And every single time we create a new subnet, it's going to be associated by default to our main root table. Now, for that very reason, we probably don't want our main root table to have a way out into the internet, because then every single time we provision a subnet, what's going to happen is it's going to be internet accessible. So what we really want to do is go ahead and create a new root table, and we're going to call this my internet root out, something like that, or you could say my public root table, whatever floats your boat, and we're going to put that into our custom VPC. So we've gone ahead and created this root table. So this is an entirely new root table to our default root table. The next thing what we want to do is enable internet access. So to do that, we go over to roots, and we're going to go ahead and hit edit, and in here we're going to add another root, and all we're going to do is say o.o.o.o/o, and the target is going to be our internet gateway, and we're going to go ahead and hit save. Now that will then allow all internet traffic, basically everything that sits within this root or every subnet that's associated to this root will now be a public subnet. For consistency, we might want to add in a root out for IPv6 as well. So we need to do that basically. So 2 colons, a /, and then a 0. And again, select your internet gateway and go ahead and hit save. This will now give us internet accessibility for both IP4 and IP6 for any subnet that's associated with this route table. So I hope that makes sense. What we're going to do now is we're going to go in and associate one subnet with our route table. So we're going to go in and hit edit, and I'm going to do my very top subnet, so 10.0.1.0 to US East 1A. That's going to be our public subnet, and then our private subnet is going to be 10.0.2.0. And what we're going to do now, once this has been associated, so you can see it's now associated with this route table. So the next thing we want to do is go in and test this. So we want to see if our EC2 instance is both publicly available and not publicly available. So we're going to launch one in our public subnet and one in our private subnet. But before we do that, let's just go over to subnets. And it can be a little strange, the UI, but if you scroll all the way over, you can see here auto-assign public IP addresses. And essentially it's yes for all your default VPCs. Again, if you want to make it easier to view, just click on order by VPC. And by default, no, we're not auto-assigning public IP addresses. Now, of course, for our public subnet, we want to auto-assign a public IP address. Otherwise, we won't be able to access that internet, that EC2 instance. So in here, I'm just going to go in here and go to subnet actions, and I'm going to go to modify auto IP signings, and just click in and enable auto-assign public IPv4 addresses, and go ahead and hit save. That will now automatically give me a public IPv4 address. So now we're ready to provision our EC2 instances. Let's go over here and click on EC2. And then in here, we're just going to go ahead and launch an instance. We're going to be pretty standard. We're going to use the Amazon Linux AMI. I'm going to use a T2 micro, configure my instance details. Now you're going to see a dead instance on my screen. It's because I forgot to change my VPC to my my custom VPC. I accidentally launched an instance into a default VPC. So make sure you change it to custom. Then go ahead and pick your subnet. So we want this to go into 0.1.0. Auto assign public IP address. See here it says use subnet setting enable. So basically, if I hadn't changed that, it wouldn't have gotten a public IP address. I'd have to go in and do that manually. Leave the roles for now. We don't need any roles. Leave everything else as default. And we'll go ahead and add our storage. And then we'll just go ahead and add our tags. I'm going to add this tag. So I'm going to call it name. This will be web server 01. My last name was public web server. go ahead and configure your security groups. Now, with security groups, try and select an existing security group, and you'll see that you can only select the default security group. So if you had a security group in your default VPC that was like your WebDMZ security group, note that you can't select it in here. So security groups don't span VPCs. Security group will only exist within the VPC that you create. So we probably want to create a new VPC security group. I'm going to call it, instead of Launch Wizard 1, I'm going to call it WebDMZ. So it's my demilitarized zone. And again, I'm going to do that for my description. I'm going to add a rule. I'm going to allow HTTP access in to all both IP4 and IP6. And obviously, I'm going to allow SSH. Again, I'm doing it to the whole world. I'm just doing that to keep it simple. Go ahead and hit review and launch. And go ahead and launch it. Choose a key pair that you have access to. I've been playing around with my key pairs quite a bit, but this is a key pair that I definitely have access to. And go in and launch the EC2 instance. Next, we're going to go ahead and view our instances, and we're going to launch our second instance, which we're going to launch into our private subnet or security group or availability zone. So if we click in here, we want to go over to our custom VPC. We want this to go to 2.0. So there we go. We're going to auto assign public IP, use the subnet settings. So right now it says disable, so we're not going to get a public IP address. And we're going to leave everything else as default. Add our storage, go ahead and add our tags. I'm going to add this name. I'm going to call this my private server. And I'm going to go in and configure my security groups. I'm going to choose an existing security group. I probably just want this in the default security group because I don't want it to be open to the world. I'm going to go ahead and hit review and launch, and I'm going to go ahead and launch this instance, and I'm going to choose a key pair that suits me, which is this one, and I acknowledge, and there we go. So we've launched our two instances. Let's go ahead and have a look at them. So they are pending. Just going to pause the video here. Okay, so these have now provisioned. We've got our web server, note that it has a public IP address. We've got my private server, note that it does not have a public IP address. One is in US East 1A, one is in US East 1B. So there's no way for me to connect into this server because it has no public IP address just yet. So to test if this is internet accessible, all I'm going to do is copy and paste the public IP address into my clipboard, and I'm going to go over to terminal and try and SSH into it. Okay, so let's see. So this is what I need to type to connect into it. So SSH EC2-user and then the public IP address -I and then our private key. And there we go, I'm able to connect. So it is definitely internet accessible. I can go in and do elevate my privileges to root. So sudo su, and then I can go ahead and do a yum update -y, and that will go ahead and do updates. Okay, so this is essentially what we've just created. So we attached our internet gateway. We then created a new route table, which was our public route table, because we didn't want our default route table, which will automatically associate with any subnet that we create, to be internet accessible. So we created this, and we created a route out to the internet with our o.o.o.o. We pointed that at our internet gateway. We've left our network ACLs alone for now. We've only got one. We have two security groups. We've got our WebDMZ security group, and we've got our default security group, and we've provisioned two instances in two different subnets. So one in our public subnet and one in our private subnet. Now, right now, these two instances would not be able to talk to each other because they're behind two different separate security groups in two different availability zones, and we haven't allowed permissions for them to talk to each other. So that's what we're going to do in the next lecture. So go grab a coffee, and I'll see you in the next lecture. Thank you.